Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 2.6, day 1, entitled Combining Functions. And today we're going to talk about sum, difference, products, and quotients of functions. So we're just going to talk about the first objective today. Okay, now basically when we're dealing with functions, we can take two functions and we can add them, subtract them, multiply them, and divide them. And when we're dealing with the sum and difference and product and quotient, we have to remember that their domain is going to be the domain of all the stuff in the first function and all the stuff in the second function. So we have this situation where we have an A intersection B. So it's the stuff that's going to overlap. Okay, so I think I said that backwards. It's the stuff that's in A and the stuff in B together. The stuff that overlaps. It's not all the stuff in A and all the stuff in B. So we want to find that intersection, the part that overlaps. And remember, when we're dealing with dividing, we can't divide by 0. So we're going to add and subtract and multiply and divide functions today, as well as finding their domains. And here in example 1, we have two functions. We have f of x equals 1 over x minus 2, and then we have g of x equals the square root of x. Excuse me. And before we get going on adding and subtracting and multiplying and dividing them, I want to find their domains first. Now, the domain of that first function, 1 over x minus 2, is pretty much anything that we want, anything that we can put in for x except 2. So that's the restriction on the domain for that first function. We can't have x being 2. And for my second function, the square root of x, when I'm taking the square root of some number, that number has to be greater than or equal to 0. So that is the stuff that I need to consider for my domain for both functions when I add, subtract, multiply, and divide them. Now, luckily for me, if I'm dealing with everything greater than 0, this x is not equal to 2 also falls in that region. So I could say my domain a couple different ways. I could say x has to be everything greater than or equal to 0 and not equal to 2. Or I could write it with my set notation, where I could go everything from 0 to 2, and then everything from 2 up to positive infinity. And we'd want our symbol in there as well. Okay, so now to actually add, subtract, multiply, and divide these functions, when I'm writing my addition function, I'm just going to write f plus g of x. And then I'm going to add the two functions together. 1 over x plus 2 plus the square root of x. Now you could find a common denominator if you wanted to, and you could multiply the square root of x by x plus 2. Your book's not going to do that, so you don't have to worry about doing that either. For f minus g of x, we just write our notation like that with the f minus the g in the one parenthesis. And then I'm going to have 1 over this x plus 2 minus the square root of x. So I'm doing f plus g, where I add f and then g, and then here I'm doing f minus g. So this order matters. I have to do f and then minus the g function that I was given. Okay, when I multiply them, you can multiply in any order. Your book likes to write the f and the g right next to each other. I like to put that little dot in there for multiplication. Okay, now when I multiply them, I'm really taking 1 over x minus 2 and I'm multiplying it by the square root of x. And since I'm multiplying, I can multiply across my numerator and my denominator. So I can kind of combine those into one big fraction. And then for my final function, the division, I'll have f divided by g times x, or of x. Now here, when I'm dividing, I would have 1 over x minus 2, and then I would have it as divided by the square root of x. Now I can't have a fraction within a fraction like this, so I have to multiply by the reciprocal, 1 over the square root of x. So that's going to cancel out my stuff in the denominator here, so now I'll get one big expression, 1 over x minus 2 times the square root of x. And then here we probably want to put our restriction in that x cannot be equal to 0, because we don't want the denominator to end up being 0 for that problem. And if I put 0 in to the square root, I would get 0 times anything, would make that 0. I also don't want x to be 2. Okay? So we have to remember that when we have a fraction like that, we don't want to have our denominators equal to 0. We could put a restriction like that on here for the multiplication part. Here we wouldn't want x to be equal to 2 either on this one, and on this one, and on this one. So for the first three, we'd have that restriction where x cannot be equal to negative 2, or positive 2, sorry. Okay, then for the other part of example 1 here, part B, they want us to actually evaluate our functions. So those 4 functions that we found on the previous slide we're now going to use, and we're going to substitute in 4 for each of them. Okay. So for f plus g of 4, f plus g on the previous slide was just 1 over x minus 2, so now that'll be 4 minus 2 plus the square root of 4. So that's going to be 1/2 plus 2, so 2.5 or 5/2. Okay. Get used to writing things as improper fractions. For f minus g, remember order matters now, of 4. So I have my f function, and I'm substituting the 4 in there, minus the square root of 4 for my g function. So now I have 1/2 minus 2, so that's going to be negative 1.5 or negative 3/2. For my multiplication function, f times g of 4, I have 1 over 4 minus 2 times the square root of 4. That square root of 4 is going to be in the numerator. So you could think of it as 1/2 times 2, or 2 over 2, which is just 1. And then my last one, the division, I'll have f divided by g of 4. So that is going to be, now let's see, this one when I rewrote it, I had 1 over 4 minus 2 times the square root of 4. I had them all in the denominator like that. So that you can double check on the previous slide. So that's really going to be 2 times 2, so that will be 1/4. So you're going to have some problems in your homework where you need to add, subtract, multiply, and divide the functions and their expressions. Some where you have to evaluate them, and then ones where you have to find the domain as well. Now the last concept we're going to talk about is graphical addition. And sometimes when the book talks about this, they kind of show you a picture like this next slide, where here's your 2 functions, and you want to add them together. Okay, so here's your f of x function, And there's your g of x function. And then when they add them together, they just tell you, oh, you get this function, you get this purple function. And you kind of think, wait, where did that come from? Well, what we have to do is we have to find some ordered pairs for our f of x function and some ordered pairs for our g of x function, and then add those y values together. And that will give us the points that we can plot for our f of x, or f plus g function. So, for example 2 here, it's our last example. And we've got quite a few data points here on our graph, but we'll just look at the whole values. Okay, we'll start at -1, and we'll do 0, and then 1, 2, 3, 4, 5, 6, 7, 8. So our graph goes from -1 all the way up to 8. Okay, so if you want to make 3 separate tables, you can. You can make a table of values that goes from -1 to 8 for the f function. You can make a table of values that goes from -1 to 8 for the g function. But then you definitely have to have a table of values for your f plus g function. So I'm going to have my x values and then my f plus g of x values. So I'm going from -1 to 8. See if I can squeeze them all in. There we go. Okay, now basically what I'm going to do is I'm going to find the f value and then the g value, and I'm going to add them together. So by the f value and the g value, I mean the y, the output for your f function and your g function. So at -1, it looks like my f function had a value of 1, and then my g function had a value of 4. So 1 plus 4 will be 5. And then at 0, looks like I had a value of 2, and then probably 4 again. So 2 plus 4 will be 6. At 1, let's see, the f function looks like it was at about 1.5. Oh, I'm sorry, 2.5. And then here, the g function looks like it might have been at 4.5. So there's a little estimation here that we're doing. How you read the graph or how you interpret it might be slightly different than someone else. Okay, at 2, looks like we were at 3 and 5. That's good because they're whole numbers. 3 and 5 is 8. At 3, looks like f gave me a value of 2. And then g, oh, maybe like 5.25. So 2 plus 5.25, that would be 7.25. And then 4, let's see, that looks like 1.25. And g, oh, maybe let's do 5.5 because it's kind of coming up a little bit more than the previous. So 1.25 plus 5.5. And when you're doing this, it might be good just to go with every quarter value, so that way you're not dealing with decimals that are like 0.3, 0.67. Okay, be kind to yourself when you're estimating. Okay, so now we are at 5. Okay, so 5 has a value of maybe 1.25 again, and maybe 5.25. So 1.25 plus 5.25, that's probably about 6.5. And then at 6, this might be like 1.75. Oh, here we get a whole number again. That's 5. So 1.75 plus 5, that's 6.75. And then for 7, I have 2.5 and 4.5. So 2.5 plus 4.5, that's going to get me 7. And then my last value for 8, that's good, these are whole numbers. I've got 3 and 4. So 3 plus 4 is going to give me 7. So then these are the points that I could graph. Let me graph in a different color here. Let me do green. So at -1, I could do 1, 2, 3, 4, 5. And then at 0, I could go up to 6. And then at 1, I could go up to 7. And then at 2, I'd be going up to 8. So that's probably off my graph there. And then at 3, I'd be at 7.25, so maybe right about there. And at 4, I would be at 6.75. 1, 2, 3, 4, 5, 6.75. And then another 6.75. Oh, that was 6.5. Okay, so 6.5. And then another 6.75, so it dips down and goes back up. And then we're at 7 and 7. Okay, so then if you connected your points there, your graph might look something like that. So you see how it still has that little curve that the f of x function had, but it's not quite as steep or as pronounced because g was a more gradual function. So that's really the best method I know of to add functions when you're given a graphical representation of them. So your set of homework problems to practice these concepts is fairly short, but don't think that that means that it's not worth doing, because tomorrow we're going to be taking a look at composite functions, so you need these skills in order to do that. If you have any questions, come on in and see me before school.